teacher, back at it again with another teacher.
Okay, so we're back. Sorry, we lost power. All right, listen up. Jason. Okay. All right. So when we last left off, before the power went out, we were about to evaluate this matrix product involving an inverse. So as you can see on the cast here, I put in the matrix. I've got the inverse on top. Not a good idea. Okay, so if you do that, you'll get this. Okay, so it's a pretty ugly fraction, but we just chose random numbers. Now, what if I wanted an answer with some decimal places instead? Control Enter, that's right. Okay? So, knowing how to use technology is one of your outcomes. So you should know how to convert a fraction to a decimal on your CAS calculator. So Control Enter. Okay, we are almost done. I've got one more thing to explain to you, and then I'm going to let you go. Do you still need a piece of paper? You still copying? Okay, so the next thing I'm teaching you is not in the textbook. It's in the study design for the Year 11 course. I'm not really sure why it's not in the textbook, but you still need to know this for next year, so it doesn't hurt to cover it. Yes? Is it relevant? Thanks. I would hope so. Okay. So this time I'm going to construct a 2x2 matrix, and I'm not going to tell you what the numbers are. I'm just going to call them A, B, C, and D. I'm going to define a quantity called the determinant. Well, unfortunately it's not, it's just a mathematical quantity of a matrix. So we abbreviate it to DET for determinant, and then we write brackets around it. And it's a number. The determinant of a matrix is not a matrix, it's just a number, and it's this. A times D, so this diagonal, minus B times C. So, let's do an example. If I tell you that the matrix capital B has these numbers, what is the determinant of B? Yes? Yeah. So you do this. The diagonals and find the difference. Okay? So A times D minus B times C. In this matrix, A and D are 5 and 4. B and C are 2 and 3. One more. So all I've done is I've changed 3 to minus 3 here. What's going to happen now? What's the determinant of this matrix going to be? you want the diagonal for the first product. It does? Yes. Yeah. It doesn't matter because these two are the same. Yeah. Alright, so I'll keep it consistent, okay? 5 times 4 minus. So if you've got two negative signs, they become a positive sign when multiplying. Sorry, I never evaluated this. 20 minus 6 is 14. 20 plus 6 is 26. Okay, so the reason why I'm teaching you this is because you need it next year. It's in the study design. It's not in your textbook. It doesn't hurt to learn this. This is one of the more difficult things next year. So even if you don't grasp all of it this year, when you meet it next year, you'll find it easier because you've seen some of it before. Okay, so why do we bother with calculating this number? So here is punchline. Is it the punchline? I don't know what to call it. Here's the main point. If the determinant is 0, if you try to solve a system of simultaneous equations where your matrix has a determinant of 0, then there is going to be no unique solution. However, if the determinant is non-zero, then there is a unique solution. Right, so there's one question on the assignment where I ask you to calculate the determinant of a matrix. So, for example, if I go back to what we did earlier, sorry if you're still hopping, I might be able to do this. I'm planning to get a drawing tablet, and then I can just have it all on the screen here. I won't have this. That's alright. I'm getting down to Melbourne next week, so I'll be able to pick one up. Now, okay, let's just do a quick example. What will be the determinant of this matrix here? What will we need to calculate here? Yep. Yeah. So whatever that number is, the number is, I'll just show it on the screen, 33. Yep. Okay, is that number 0 or non-zero? It's non-zero. So based on this theory, we know there's going to be a unique solution. So basically, what I'm trying to say is, if you've got a matrix and you calculate the determinant and you find that it's 0, you won't be able to solve the simultaneous equations. This is heading into next year. I'll just draw 2 pictures for you. You don't need to get this down. Well, you'll see it again next year. If you've got a situation like this, where the 2 lines have an intersection, the determinant is 0. But if I have this situation, where the lines are parallel, are you going to have an intersection? No, no intersection. Because by definition, parallel lines never meet. And if you try to solve this, you'll find that the determinant is actually 0 here. Okay. All right. It was heavy for me too. All right. I'm ready to let you go to do some work. Today we covered, I believe it is 9H and 5H and 5K. Yeah, so today we covered 5H and 5J. All right. Most of the work you do will be on your CAS calculator. So no questions? Okay. I'm sure there will be, so just call me over if you need help, all right? All right, you've done well.